Alright, when you're doing inverse problems, I've noticed students in the past kind of just struggled, so an easy way to just help you do the problem, notice how there's no equation. So just make it an equation. You can put something like theta equals the inverse of sine of negative 1/2. Everyone say equation. Make it an equation, because you need to find the exact value. Well, my exact value is theta, or x. Remember back in the day when we said the inverse was using those arrows? Do you guys remember that? So you're actually doing the same thing. All you have to do is switch them. What are you doing? Now pay attention. When you are switching them, this negative 1 is like an on and off switch. So because you switched them, you're going to take it off. Sine of theta equals negative 1/2. I need to figure out theta. If I think about in the unit circle, where is sine negative? Well, I'm going to have two answers, correct? Theta is equal to, there's two locations if you're thinking about the unit circle, is 11 pi over 6 and 7 pi over 6. You just look at your unit circle, you can create one. But here's the hard part. If I look at my two answers for the inverse of sine, 11 pi over 6 is not in my restricted domain. And 7 pi over 6 is not in my restricted domain. So does that mean I reject both answers? The answer is no. I can use coterminal angles. What can I use, class? I can subtract 12 pi over 6 on each of these. That'll give me theta equals negative pi over 6, and this one will give me negative 5 pi over 6. If I look at my two solutions now, is one of those between negative pi over 2 and pi over 2? Yeah. Which one? Negative pi over 6. So I'm only accepting this answer. So let's review. Set it equal to something, make it an equation, switch them, take off the inverse sign, think about it. Are those between my new restricted domain? If it's not, use coterminal angles. I rejected this one because it's not in here. This one is.